as mentioned, I'll talk about the role of hydrogen-related infrastructures in Europe. Um, and in a Danish context, we have been talking about 6 prerequisites for large-scale power-to-X. I'm a little bit in doubt if you see the 6 points now.
Not yet.
Yeah. There's something about how this is working that is annoying me.
We can see your mouse pointer, and I've
see...
seen the first bullet point.
So what we need is quick access to low-cost green electricity, right? We need that there will be a demand for green international transport and also from industry, and this might need some regulation. We need to limit the biomass import to sustainable levels because we have a biodiversity crisis and we will have limited sustainable biomass available. And if we had unlimited biomass, this would be the cheapest way to produce fuels. And then we need access to biogenic CO2, which could be in competition with CCS to achieve negative emissions, for example, needed to compensate for emissions from the agricultural sector. Then what others have also been mentioning, we need this smart sector coupling in order to really avoid too much losses of efficiency and also to allow the electrolysis to help the power sector integrate renewables via flexible consumption. And then we need further technology development. We need good regulatory framework. And all this needs to happen in order for the power-to-X fuels to really come into play large scale. I want to tell you a little bit about a study that we completed last year, which was called a Unified European Hydrogen Infrastructure Planning to Support Rapid Scale-up of Hydrogen Production by my PhD student, Yannis Kontouris, and other colleagues. And basically, what we looked at were 3 different scenarios. We wanted to look at a scenario where we allowed imports and blue hydrogen as well as green hydrogen, one where we only allowed green and imports, and one where we only allowed green hydrogen, and where we were looking at self-sufficiency in a decarbonized scenario. So this is what I'm going to go through quickly. We started with the demands with inspiration from the hydrogen backbone, focusing on the demands for industry, feedstock and energy, and then transport. So for the power sector, we have endogenous modeling of this, and for the building sector, we don't really see any demand for hydrogen for heating. We looked at supply options from North Africa and also from Eastern Europe. And we used the Balmoral model, which is an energy system model that covers all of Europe. It looks at power, heating, gases, fuel demands, and it does a techno-economic optimization, minimizing costs of both generation and transmission across Europe. The electricity mix is something that you might recognize from some of the other speakers. There's a lot of wind, and basically the onshore wind is limited by potentials that we assume are available. And then when we've used those potentials, we really see offshore wind coming in more. There's a lot of solar, limited fossils, some hydro. So this is kind of similar to what you've seen before, but then we have it in different places with a lot of solar in the south and a lot of wind in the north. And what we wanted to look at was kind of the competition between the north and the south. Denmark, where I come from, being in the north, and we wanted to see, well, can we really compete with what is going on in the south? And what we see is that we have around 800 terawatt hours additional of electricity demand if we move towards green hydrogen. So this is the difference from allowing blue hydrogen in the mix from the beginning. So the results in 2030, we hardly see any hydrogen in the mix. The demand is not very big. By 2050, the demand is assumed to increase by 5 times. And then we start to see these corridors established. And these corridors are both based on, in some cases, where there is natural gas pipes available that we can repurpose. We look into that. This is a cheaper option, if not newly built pipes dedicated for hydrogen. And we see a mixture. So the balls kind of indicate how much hydrogen production capacity, and then with light blue we have the electrolysis, and with the dark blue we have the blue hydrogen. We don't see any gray. And we can see these big corridors coming from Spain, for example, into France and further on to the center of Europe, and also from Ireland and coming in. Not so much from Denmark in this stage. Then looking at what are the hydrogen imports, I show down in the right corner how much with the red is imported in terms of terawatt hours in 2050, and what is the potential. And what we can see is that we don't utilize the full potential. There is actually a good potential within Europe to produce cost efficiently. And what we see is a large electrolysis capacity and less blue. Then if we look at the scenario where we take out the blue option and go green, what we see is here what are the storage levels with dark blue, and what is the line utilization with red. And we can see that we need less capacity, but it's more utilized from Spain, for example, and also a higher utilization from Ireland. And you can see the numbers. We go from 50 terawatt hours of hydrogen storage in the base case, and it increases in the up to 66 terawatt hours in the green scenario, while the networks also increase from 255 terawatt kilometers to around 400. One note to look into is that when we do these 5-year steps, then we see in an intermediate period that blue hydrogen might be feasible. Obviously, this depends on the natural gas price at a given time, but it might be feasible in an intermediate period, and then we're kind of stuck with the capacities going forward. So there's a possible lock-in effect. If we then go from being green to also being self-sufficient, we see that some of the corridors, for example, from Italy going up, are much smaller because these were relying to a large extent on imports. And of course, by now we don't have blue in the system. And then we looked at how much extra electrolysis. We're going from 450 gigawatt to 505, and I think the EU strategy says around 450 gigawatt, but they are also planning on allowing imports. So we're quite in line with the targets on that point. And then the good news was that if we compare the base scenario where we allow everything to a scenario where we go green, we only have 30% extra costs to the system. And if we also want to be self-sufficient, it's also it only adds an extra percent point. So the good news is that it's not necessarily prohibitively expensive to become both green and self-sufficient in a European context, and taking into account the many uncertainties, of course, in the costs of natural gas, of electrolysis, and so on. This is not a scary size. So coming to the conclusions, we can say that hydrogen production, we think, will mainly be located in the periphery of Europe, mainly south, to supply the west and central of Europe. But still with some production in the north. There might be a lock-in effect of blue hydrogen by 2035, which could imply a long-term dependence on natural gas. Some imports we see to Europe, but not the full potential. And this green hydrogen European economy, of course, requires a very rapid infrastructure scale up and investments in renewables. And we can also say that, I mean, we're assuming a large build out of PV in Spain, for example, and this, of course, requires social acceptance from Spain. From the people. Then we see that storage provides flexibility, both intraday and seasonal, depending on where the electricity comes from, for example, for integration of PV. And with storage, we have much less need for grids. And we were looking at onshore salt caverns as a possibility. And then we see that Europe can become self-sufficient and utilize green hydrogen at a relatively small additional system costs. Of course, what we're looking into is also what exactly are the demands going to be for example, for fuels for international transport. And there, I think some of the jokers are. What are going to be possibilities in terms of, for example, CCS on ships? Is it going to be cheaper to do negative emissions capturing? If we're going to capture CO2, is it going to be cheaper to then have CCS or to produce the green fuels? Maybe we'll see a mixture, but this is the hydrogen demands is definitely a joker. Also, as we see more and more electrification options, both in the transport sector, but also in industry. So I think with that, I will close my presentation and hope I didn't spend more time than allocated.
Professor Münster, you did a brilliant job. We are 2 minutes early, and therefore you have the distinction of having some questions and answers. Anybody want to put a question to Professor Münster?
Actually, yes, Alex, there is one question in the chat. So very interesting results, especially on the favorable deployment of on the favorable deployment for hydrogen. Do you consider feasibility of deployment due to land or resource availability in the related countries?
So, yes, I mean, in terms of renewable potentials, or I'm a little, so in terms of the renewable potentials, we have a quite thorough going through the potentials for each country or region we are looking at, both in terms of PV and wind potentials in particular. And what we can say is that what we're looking into is maybe what is the economic potentials, and we're also trying to take into account what is the socially acceptable potentials. But this is, as we all know, a dynamic thing. It changes over time and from one region to another. But yes, we are looking into that. Yes, did that answer the question, do you think, Statis?
Sorry, yeah, one clarification. The question was about water electrolysis, sorry.
Yes, I was talking about the renewables for water electrolysis. What we see in terms of water is that there is now possibilities coming up in terms of using water from grey water from wastewater treatment plants where you can further refine it to be used for. This is options we're looking into in Denmark, but there's also options of doing it together with desalination. And here we see that the cost of desalination is not prohibitive and is not near the costs that we see, for example, for buying electricity. So we don't think that is going to be prohibitive to use salt water for electrolysis.
Okay, I don't have any other question in the chat, Alex.
Shall we then close the morning session? Thank all our speakers for indeed flooding the zone. There's a great deal that I want to absorb, and I need to sit down with the presentations, the publications. I'm sure we all do. We start again at 12:30, Stathi.